Thank you. All right, so we're going to talk about the city of Topeka, Kansas, and a Lifecycle investment story. Just quick agenda. We're going to start out with introduction to Lifecycle modeling. It's essentially the basis of science, if you will, that we implemented in Topeka, and we implement for many folks in Australia as well as in North America in order to develop the story. And we're going to develop a story that is exemplified through story maps to visualize what Topeka is doing with their funding. And then we'll end up with questions and answers. Before I get into it all, let's just verify where Topeka is. There it is, right smack in the middle of the USA. We call it the heartland. When I presented this the other day to my Australian mates, they asked me political questions. What's the political landscape? Interesting question. And my first answer is, well, I work in lifecycle modeling and GIS. We're pretty much politically neutral, right? That the sciences that we bring to the table apply to everybody, no matter what their politics. But nevertheless, they wanted to see where Topeka stands. And there it is, right in the middle of the sea of red. But as I mentioned, it's pretty much politically neutral. The city itself is 49% red, 49% blue. So there you have it. That's the political situation of the city of Topeka, the state of Kansas. It is the capital of Kansas, and you can see the population, 127,000. Let's bring it back to the science of life cycle modeling. So we like to think of lifecycle modeling as a science of when. Esri has had this motto, if you will, that GIS is a science of where. So this is a science of when meets the science of where. And when we're talking about the science of when, we're talking about time. So we put time here on the x-axis, and we put service state or condition up here on the y-axis. And this gives us the framework to develop a life cycle model expressed in the sense of a degradation profile. So what this line here represents how assets deteriorate or degrade over time. Their service state or their condition diminishes over time. And what we can do with the sciences of life cycle modeling is to interject rehabilitations at a certain cost and replacements at a certain cost very strategically as the assets deteriorate. So that's the basis of life cycle modeling, and we apply it through our product, Aesthetic Predictor. That's a screenshot of it in the screenshot on the left there. And you can see this is a decision framework that we're presenting here. So the science of life cycle modeling allows actually some pretty sophisticated decision making. And in this decision-making framework is about pavement modeling, right? And once we have set up this decision framework, we can bring the results of the model back into ArcGIS, and we can present them in various ways. One way we can present them is a time-based feature layer. So we can essentially illustrate how the service state of our infrastructure changes over time, represented by the color coding in the GIS. So there's some of the basis of what we're talking about here. Now, when we develop these life cycle models, we have a purpose in mind. Our purpose is to answer some very important questions that may come from the public and from council. Now, these questions may be presented in different wording, but I'm just going to present some illustrations, some examples of the types of questions that life cycle modeling can help you answer as a community. We're all about providing service levels to our community. We want to maintain our infrastructure so that we're providing the services that we need to provide to the community. And that takes money. It takes a certain amount of money. So the question is, what's the best service level that we can get for any amount of funding? That's one question. Another question we might ask is, what will be the future asset performance if we change the current level of funding? So if we add funding, we reduce funding, how is that going to affect the future state of our infrastructure. Another one that I particularly like is we may have a target service level that we're trying to achieve. We're not there at this point in time. How much time and dollars is it going to take us to get to that point? What are our options? So when we start asking these types of questions, certain terms emerge. The terms that we speak in are service, asset performance, and funding. And this is the basis, this relationship that we're going to be telling through the story of Topeka, through story maps. A couple other slides. We're going to be talking about roads today, but the science of life cycle modeling is applicable across the entire built infrastructure: roads, water, sewer, pathways, parks, buildings, facilities, treatment plants. If it degrades over time, it's applicable to life cycle modeling. And we tell that story, as I've already stated, through story maps. I just threw this one up here because this is just one example of story maps. We do them all the time to present the story. So this is essentially showing the before or the current state of the infrastructure, and we move that slider across that's available in Esri story maps, and we can show what the future state of the infrastructure is going to be. Very easy to recognize color coding where red is bad and green is good. So let's bring this all back to Topeka's story. And I like to actually frame this as the tale of the half-cent sales tax. At the end of the day, when we're talking about funding, we're talking about some revenue source. In the public sector, a lot of that is tax-based. And so in this case, for roads, it's the story of the half-cent sales tax. And it's a story that originates out of City Hall. And what we're hearing out of City Hall, from the city councilors, if you will, is that citizens are complaining. The road network is in poor condition, according to the citizens. We need to improve that. We have that conversation now with the Public Works Director. The Public Works Director brings in the science of pavement management. And in the USA, we measure the service state or the condition of the pavement on a pavement condition index. That's what Ian was referring to earlier. We measure it on a scale of 0 to 100, where 0 is absolute worst and 100 is a brand new road. So Topeka right now is a state of 55. The actual goal is 65 or better. And we did 15-year life cycle models to illustrate that. So that's one side of the story. The other side of the story we're hearing from City Council, can we eliminate that half-cent sales tax? So there you go, right? The typical situation. One story is we want to improve our roads. The other is, can we eliminate that tax? Well, we need a story to tell that. So we actually developed 2 story maps. I say we working with the city of Topeka. They actually have some really good GIS expertise. Darren Haig leads the show there. Call out to Darren. And we developed 2 story maps. First was an internally focused story map, which got City Council and others on board internally. And then City Council needed to sell it to the public, right, where the tax dollars originate. So I'm going to illustrate their story in 2 story maps. We'll switch over to that now. Here's the first story map, developed internally. What I didn't mention, we actually used 2 structures of Esri story maps. The first is their standard structure, which is presented here. And when I switch over to the public-facing, that's the new presentation tools that Esri has introduced in the last year for developing story maps. So let's walk through this story, internally focused. The existing condition of the road network, as it is today, actually last year. So you can see that it kind of reflects what the citizens are saying. There's a lot of red in there, a lot of yellows, oranges, not a whole lot of green. So at this point in time, their existing budget, including that half-cent sales tax, is $24 million a year, specifically focused on pavement management. So we developed some alternatives using lifecycle modeling, our tool predictor, integrated with GIS. This output that you're seeing is directly generated by our tool, output directly as a feature layer to GIS. And it's a time-based feature layer. And what we can illustrate now with our output is here it is, the current conditions, but what will it look like in 15 years with the $24 million using existing strategies? Not too bad. We're seeing a lot more greens. But we're also seeing some pesky reds in there. So we worked out in a workshop setting in the Public Works, we don't like those pesky reds. For a matter of fact, you'll see that they represent about 10% of the roads that are still in that end-of-life situation. That, can we improve this? So again, using lifecycle modeling tools, now that we have these, applying all the different types of treatments through that treatment roadmap that we saw earlier, how can we change that? Fundamentally, if we're more aggressive on our overlay type of treatments, we can actually gain more out of that same amount of funding, that same $24 million. So you can see here, we called it Alternative 4 as we were developing these, and the other was Alternative 2, that there are more yellows in this, but we significantly reduced the number of those bright reds. And we can illustrate this as well using graphics, right? All of this developed with Esri ArcGIS Online tools, where if we look at the road score distribution here, we can see that first model, that Alternative 2, their existing treatment strategy and their existing budget, 10.5% of the roads end up at an end-of-life state. So it's more than just the average condition. It's also how many roads are getting to that end-of-life state. Using the other alternatives, same budget, but more aggressive with the overlay type of treatments, after 15 years, we're reducing that in half practically, 4.5 or 4.7%. Now, I didn't actually introduce the $31 million budget. There are all kinds of what-ifs they wanted us to perform. So certainly, what if we increase the budget? That's always part of the equation. You're probably asking, though, what about that story if we removed that half-cent sales tax? That's way down here at the bottom. Frankly, it didn't take a whole lot of convincing. So we're just going to let Esri Story Maps generate that. And what we can see is that we're up to 20% of roads that would be in a failed state if we eliminated that half-cent sales tax, which amounted to about half of the total budget that they had. So and they did not reach that overall PCI score, so it pretty much stayed flat. They were able to keep the average about the same, but as you can see, they were sacrificing a number of the roads that would reach the end-of-life service state. Another graph that we had that we developed was this average road condition comparison. This was interesting, as I had mentioned before, just the average PCI or the average score of the road doesn't tell the whole story. So you can see in each of these funding scenarios, Alternative 2, Alternative 4, and that 31 million, they all ended up about the same average PCI score. So this part of that story, at least for internal, working with Public Works and City Council, is understanding that average, even though that's what they asked them for, is not the total story. It's also about the percentage of assets that actually reach that end-of-life state. So, needless to say, it didn't take much convincing that the half-cent sales tax really needed to stay. City councilors are convinced, other internal decision makers are convinced. But now the next challenge is we need to convince the public. After all, this is a tax on them. So again, a call out to Darren Haig, who developed this story map using Esri's newer tools for developing story maps. He developed this externally focused. This is available on the website on Topeka's website, Fix Our Streets. So this is a public education tool, all supported by our life cycle modeling. So it starts by introducing the sciences of pavement management. So we're educating the public in terms of pavement management, life cycle modeling, all the decision factors. And it was really pretty amazing, the feedback that they got. You know, it was like, wow, I never knew you folks went through so much in order to decide how to treat our streets, how to keep them in a good state of repair. And it goes through explaining all of this, the pavement condition index, the treatment strategies, the funding, their processes, supported again by all those maps, all this generated by Predictor integrated with Esri ArcGIS Online. Treatment strategies, how they were applying different treatments to different neighborhoods. So this is other output generated by our tool that they were able to illustrate to the community where they were applying, not just how they were improving, but what treatments they were applying in different regions of the city. And for what purposes? Videos, all of this. How many of you have developed story maps? Anybody? Have you used the new tools? Yeah, they're pretty powerful. You're going to find that some of the standard tools are missing, but you can see it's a great presentation, especially for the uninitiated in the world of GIS. There's the half-cent sales tax, the projects associated with that, major rehabilitation, bringing them through an understanding of this type of treatment, reconstruction, what it looks like before and after, full depth repairs, full explanation of that along with a video. And then how their funding is allocated. There you see that big blue area is essentially the half-cent sales tax, and then along with the rest of their funding sources. And then this graph, this was also presented on the other story map too, but I'm illustrating this. This shows some of the, may I say, sophisticated decision making, if you will, in terms of the different types of treatments that are applied within the decision model, right? So I find as I go from community to community, they may term these, use different terminology. Micropaving is a term, surface seal, asphalt reconstruction, full bed reconstruction, different types of overlays, mills and overlays. All of those types of treatments are embedded in that decision model. And they're developed with the people doing this work or managing this work in the city. So you have buy-in during the development, then you have buy-in at the public works decision-making level, city council, and finally the public. And then graphs like this, how can you argue? We already have a public that's not happy with the service state of their roads. Let's educate them what it takes. We're not going to increase your taxes, but we're going to use your tax dollars more effectively, and this is what we can get for a result. So automatic buy-in, just a great story across the whole community, educating the public of the sciences of pavement management, life cycle modeling, and the power of presentation through ArcGIS story maps. And that's pretty much a wrap.